Thanks, all. So we called our presentation to you guys, Fishing with Data, talking about our bycatch avoidance programs in Alaskan fisheries. So we're going to talk about what does Sea State do, how do we do it, and then we want to overview one of our most important bycatch avoidance programs, the Rolling Hotspot Closure Program, and then talk a little bit about some policy analysis we've been involved in for the chum bycatch avoidance issues that are ongoing. So what do we do? This is the mission statement we came up with, is that we ensure timely sharing of sensitive fishing data to improve efficiency and reduce prohibited species catch. So as an independent third party, we help fishing companies collaborate with potential competitors because we have knowledge integrated across multiple fleets, not just one. So we kind of have data on what's going on in many different fleets in the Bering Sea, as well as like one fleet in Pacific Cape on the West Coast. So we kind of see what's going on across different fisheries and can help share that knowledge across different sectors. And then over the 15, 20 years that we've been collecting this database, we collectively know a lot about what can be done to avoid various species, but it gets really complicated because there's so many trade-offs between species. And so then we help the fishing industry work with the council to develop policies that achieve intended goals and are practicable for the fishery. So a brief history of Sea State is it was started in the 1990s by Carl Haflinger as a software for fishing plotters. And then by 1998, AFA established a cooperation between US companies. And so they set up the incentive plan agreements, or IPAs, which legislate industry compliance to minimize bycatch. And I think basically Carl was just best friends with John Groover, who was the shoreside pollock co-op manager. And John said that, Sea State already has this database set up, so they're the logical choice to implement the IPAs as a trusted third party for data sharing. So then by 2008 was the first rolling hotspot program for Chinook salmon. And this is a unique program setting week-long closures based on in-season bycatch rates. And it allows for vessel exemption from certain area closures if they demonstrate good performance. And we're going to go through that a lot further later. And then in 2016 was the adoption of Amendment 110, which expanded the rolling hotspot program to include chum salmon in the B season, and Amendment 111, which established the halibut avoidance program for the Amendment 80 sector. So we work with a lot of different fisheries in the Bering Sea and Pacific Cape on the West Coast. So the word cloud, I think, shows the different sectors we work with in terms of probably biomass. And so we work with pollock mainly, all three sectors for the catcher processors, motherships, and shoreside, or the catcher vessels. We work with Amendment 80 sector, and yeah, I said Pacific Cape on the West Coast, and offshore and shoreside sectors, and the Freezer Longline Coalition that catches cod and halibut, and some other sectors who see the services we provide and want to have those services, and I'll talk about those in a second. But in terms of the table shows the offshore observed vessels as of today. So we have hook and line, non-pelagic trawl, pot gear, and pelagic trawl over 18 years, 33 sectors, and over 800,000 hulls, 209 vessels, and over 31 million metric tons of ground fish. And that's just for the offshore sector, not counting the shoreside sectors that we have landings data. And so what do? We provide technical support. So we have a website where clients can check their catch versus allocations and track how they're doing throughout the season, and look back at previous seasons too. We have weekly reporting, so both in terms of how the season's progressing for target species and as well as bycatch. Bycatch alarms, so clients can set bycatch rates for specific species. So for example, the number of salmon per metric ton of pollock. And if a haul or a fish ticket comes into the observer program or the e-landings database, and it exceeds that bycatch rate, then alarms get sent out to the entire fleet with a link to the VMS track so they can see pretty much every night what's been happening the last day. And we have data and policy analysis. So as Sea State has expanded from just Carl and our database manager, Eric, who's based in Juneau, and to Steve and now me, we have more like hours that we can spend on using the candy store of data that Steve likes to say to help analyze policy options. So we can work with both the council staff and industry to identify practicable options that will achieve management goals. I look forward to talking much more about some of that in a bit. And then time area closures. So one benefit of C-State is that the real-time nature of our data allows us to set closures when issues pop up in the middle of the season, rather than slowly working through a legislative process. So for example, on the West Coast hake fishery, if their allocations for specific rockfish are low, we can analyze their VMS locations and associated bycatch rates, either preseason or in the middle of the season, and identify closure areas to help the fleets keep bycatch down and be able to keep fishing for hake. And that's just one example of the many times this has popped up. And then we have the rolling hotspot closure program that C-State implements, the specific program that's legislated through incentive plan agreements.
Thanks, Merrill. So that's an overview of sort of what we do. The next question is, how do we actually do it? And what it takes is a lot of data to run these programs. Much of what we've set up at C-State is pretty much automated, so it's running 24/7, 7 days a week, 365 days a year. And we rely on data from four major primary sources: the Observer Program, which is a federal fisheries program that collects primarily all of the data for our offshore fishing sectors, so the catcher processors, the Amendment 80 or hook and line groundfish trawl vessels. Electronic fish tickets, these are all from the either motherships or from shore-based plants that are processing fish onshore, and all of the catch accounting is done at the shore. We have VMS data roughly every 6 minutes to 36 minutes for every single vessel. And what C-State is really powerful at doing is taking all of the catch accounting, electronic logbook data, and all the information and integrating it into a single source, so you can actually track individual vessels' hauls over time and see how they're performing over the weeks and months and years of each fishery. One of the automated systems we've set up that I think is probably widely used throughout the fleet is our bycatch alarm systems. We've had interest from other fisheries around the world to set up similar things for looking at birds and albatross and other protected species in New Zealand as well. But the way the system works is essentially a vessel will go out once the observer enters in all of the bycatch data. If it exceeds some sort of threshold rate, for example, we are catching too many Chinook salmon per ton of pollock, then an automated alarm system will go out to our email lists of all the vessel captains, and they'll get an email message on their boat. And they can click any one of these blue links and then see a map on their screen that'll show the VMS tracks and locations. And they can actually click on the screen too and get more detailed information on when and where the bycatch events occurred. So this system is used to track, or helps the fishermen track where and when to go fish and avoid some of the bycatch species. The weekly reporting, again, because we're simulating all of this data, what we like to do is help many of the different co-ops we work with on the pollock fisheries come up with custom reports that allow them to provide information in a form that's very readable. My idea of a good report is something that they can look at in 2 seconds and put it away and know what the answer was. So we use really simple charts that have color codes and cumulative graphs. And once they've seen the numbers, literally, I'm proud of the fact that they look at it for 5 seconds and put it away. They got the information. I've done my job. What this report also does is it allows individual fishermen that we track on each row. Their vessels' names aren't identified, but they have a unique identifying number, and they can also figure out from which day of the week they're fishing or their buddies are fishing. But if this does get up in the public domain, nobody's names are shared, and we can maintain confidentiality with our clients. But the critical part of this is probably the bottom statement, is that these fishermen who work in these co-ops, because they're sharing information with other members in the fishery, they know when they are an outlier, and they immediately self-correct, and so they change their behavior. So by just putting up these simple weekly reports, they immediately become accountable for their actions. So this part actually turns out to be a really important part of managing a fishery. Merrill alluded to some of this. Our primary role in policy analysis is to help the fishing industry predict what will happen when the council decides to make changes. For example, we have an upcoming action right now where the council is considering putting a chum salmon cap or some sort of cap on chum salmon in the Bering Sea that would protect Western Alaskan chum salmon. What we like to do is use all of the data that we have available from us for the fishing industry and play some scenario analysis or do some basically management strategy type evaluation games where we predict what would happen if we were to close area A or area B. We've done similar analysis off the West Coast for whiting out here. There's a lot of plans to build large-scale wind farms that would compromise some of the fishing grounds off the West Coast, as well as some of the areas where the Coast Guard routinely traffics their ships and airplanes for managing ship traffic. Probably the biggest part of my time is spent participating in this bycatch avoidance program or the rolling hotspot salmon closures. As Merrill alluded to, when the American Fisheries Act was established, it allowed for the fishing industries to develop their own little mousetrap to deal with management problems. And at the time when the rolling hotspot program was developed, there was a threat that Chinook salmon closures or Chinook salmon conservation was such an issue that they were going to close large swaths and areas of the Bering Sea to the trawl fishery, and it would have been a great expense to the trawl industry. The industry responded and said, listen, we think we can do better using all of this data and managing a system of rolling hotspots, because 1 week you might be in an area where there's really good fishing for pollock and no salmon bycatch. And with the change of the tide or a change in the moon, all of a sudden a huge school of salmon will show up in the area and then the fishing becomes dirty. We need to find a way to A, detect it, B, tell the fishing fleet there's a problem, and C, tell them to move or set up a system of rules that they move in response to that problem. So what they established through these incentive plan agreements are these bycatch avoidance areas, or we call them rolling hotspots. What they are they simply areas in the ocean where the bycatch rate of Chinook salmon relative to pollock is above some base minimum threshold that we establish, or if it's just bad everywhere, we look at the areas that are the worst possible areas. How do we choose them? Again, we take all of the VMS data we have from the vessels and we join it up with data from catch accounting, and we join it up with data from the observer program. And then we can make maps or build maps, I'll show you one in a second, of where and when fish are being caught and what those fish look like. And then who is subject to the bycatch avoidance areas? The key part of this is when you close an area to fishing, you no longer have any data about that area. It becomes a data void. So the moment you close everyone out of there, you don't know what's going on. If you have a system where you're relying on people to go out there and fish in the waters to bring you back information. So the way we deal with this is we only close the areas to the poor performers, and the good performers are still allowed to go fish in the bycatch avoidance areas. This allows us to generate detailed data about what we see inside the closed areas and what we see outside the closed areas. This is a typical week of fishing that you would see in the A season. And generally what we do is we plot the VMS data. This is a couple of weeks of fishing here, but we would actually animate it. You could see how the fleet moves out of the harbor. They'll spend a week in one location, and then they'll follow the school of fish up to the north or along the 50-fathom edge curve towards St. Paul in the middle of the Bering Sea. I've colored the VMS tracks from each one of these tows here. White is a tow where it's nothing but clean pollock and no salmon. And then as you get through shades of red to dark red, we're now hitting areas where we're starting to catch 4 or 5 Chinook salmon per 100 tons of pollock. And so this is our threshold rate in which we would close the area to fishing. We manage the area through a large grid. This is the green grid. It's the ADF&G statistical areas. And if the bycatch rates exceed an area, we then draw a polygon around the toes where we have high bycatch rates, and we close that area for a week on Thursdays. I don't have the figure here, but I wanted to show you the weekly bycatch rate. If you look at salmon bycatch in the pollock fishery, it's always highest on Friday, Saturday, and Sunday, and it's always lowest on Monday, Tuesday, Wednesday. And the reason why is we put these closures in place on Friday. That triggers the fleet to move. If I put a closure on top of them, they have to move. And when they move, they usually go to find places that have higher bycatch rates than there just were. And so if that's the case, then they have to move again. And so by Monday or Tuesday, they figured out where the clean fishing is. So every time you put a closure in place, you're kicking the fleet out and kicking around the Bering Sea. So there's very interesting dynamics that happen in fishing behavior. The key to all of this is communication. Again, as I mentioned, the rolling hotspot closures go out. We'll announce the boundaries. We'll set the coordinates of the polygon, and we'll list the vessels that are subject to the closures along with various other catch statistics. And that's effectively how the closures get put in place. The question we always get asked is, do they work? We have an annual auditing system, and we have systems in place. If the vessel does fish inside the closure, we get an email notice, and then we send that email notice out to the co-op managers. In the shoreside fishery, there's a scaling escalating fine system. If you get caught fishing in that closed area, I think the first fine is $10,000, the second one's $25,000, and it goes up to $50,000 for your third violation. Needless to say, we don't get a lot of fines every year. These guys are very well behaved in terms of how they perform. I'm going to turn it over to Merrill and let her talk about the scariest thing we've had to deal with this past 8 months.
Like 3 years, probably.
3 years.
I don't know. It's been a long time. Yeah, so unfortunately, chum salmon returns to Western Alaska are low and have led to fishing closures in the rivers. And so this map shows the major watersheds with chum salmon. And unfortunately, estimates of total run size are only available for the Yukon summer and fall runs. And so this top figure shows the Yukon River chum salmon run size, and then the recent declines since about 2019 over here. And then some rivers do have abundance indices. So this lower figure shows estimates of chum escapement from a weir on the tributary to the Kuskokwim River, and that's the blue bars. And then there's a Bethel test fishery CPUE that's representative, they think, of the Kuskokwim River, and that's the black line. And so the important thing is that both of those indices show similar declines in chum salmon escapement since 2019. I realize I should have introduced that I'm shifting gears to kind of talking about this policy problem, and maybe some of you in this room might know more about it, the actual issues relating to chum and salmon in rivers than I do, because I'm more intimately familiar with the bycatch data. But I wanted to kind of go over the problem and some hypotheses about why chum returns are low, and then talk about what we've been working on for pollock trawl bycatch. Yeah, so these are some of the hypotheses about why chum salmon returns are low. So there might be ecosystem changes, in-river fishing, hatchery competition, salmon bycatch, which is both from an Area M state-managed fishery, and then the big pollock trawl bycatch is the issue we've been working on. So our first hypothesis for chum salmon declines is ecosystem and climate changes. So the North Pacific Fishery Management Council preliminary draft environmental impact statement stated that the best available science suggests that ecosystem and climate changes are the leading causes of recent chum salmon declines. And so I went through this citation of Farley et al. 2024, but again, I don't know this literature very well, but I can understand that the higher sea surface temperature led to poorer prey quality. So there's actually been a higher relative biomass of juvenile chum in the Bering Sea, but then they have lower energy density, so that makes their survival rate during winter lower. And I'm sure there's a ton of other ecosystem and climate changes happening, again, that many of you might be more familiar with. And then a second hypothesis is in-river fishing. So this is probably not likely a large driver of declines in chum salmon, but it's worth noting that commercial chum salmon harvest reached a peak of 3.5 million chum in 2018, with an average around 2 million chum. But from 2020 to present, there's been no commercial chum fishing on the Yukon, and commercial harvest has been about 25% of the average. Actually, I'm going to let Steve talk about this issue, this third issue of hatchery competition, because he's done more work on it than I have, and it's really interesting.
Well, I think for those of you who were here 2 weeks ago, Greg Rugerman did a much better job than I will ever be able to do on the impacts of hatchery competition, especially with respect to pink salmon. Chum salmon is the one that we don't catch pink salmon in pollock fishery, in the trawl bycatch. The only two species we catch are Chinook salmon in the A season, that's January through March, April. And then chum salmon show up in our fishery usually around the first or second week of July and persist right up through mid-September, early October. By October, the Chinook salmon start to come back again. So ideally, we want to try and get the pollock on and off the grounds before the fish come back. What we've noticed in our data since 2014 is our chum salmon bycatch has been increasing almost exponentially. And we were trying to understand why. So one of the issues I started looking at was the inputs of hatchery fish in the North Pacific. And you can get this data from the North Pacific Anadromous Fish Commission, which meets next week in Vancouver to discuss this amongst the 5 member countries that participate in this. But since about 2011, when the big Fukushima accident happened in Japan, Japan has really curtailed their chum salmon production. They've reduced actually almost all of their hatch reduction in Japan by almost 50% since that accident happened. In the meantime, Russia has done some really interesting experiments, and they've discovered how to improve their hatchery fish, especially the survival rates of chum salmon, mostly by relocating hatcheries from inshore rivers to the outer rivers out towards the Kamchatka Peninsula and the Shimigan Islands in that area. And they've had tremendous success, and they've doubled their hatchery production in the last 5 years, and they plan to double their hatchery production in the next 10 years again. What we've seen in the data is a massive wave of Northeast Asian hatchery fish. So these are little pie charts here from each one of our Asian or our ADF&D statistical area. And the pie charts represent the stock proportions or the genetic proportions of chum salmon from Northeast Asia, shown in the red parts. And then the Western Alaskan component that we're trying to conserve are shown up here as the little white parts of the pie charts. So what we've seen over the last, since 2014, is just a huge wave of Russian chum salmon moving into our fishery, and we see this in the data. The other thing we, of course, have seen is that chum salmon body size, just through competition since the hatcheries really started ramping up in the 1970s, have also declined significantly. And again, Greg Rugerman has done a much, much better job documenting the impacts of hatcheries, especially pink salmon hatcheries, and their linkages right through to the southern resident killer whales. So this is a big, big issue. It's a big issue for us because this is a man-made bycatch problem that's potentially threatening our fish or shutting down one of the world's largest whitefish pollock fisheries to protect a weak stock management problem. So we've really tried to deal with that.
Mm-hmm. Thanks. Yeah, so then in addition to those three, a fourth hypothesis of low chum returns is salmon bycatch. And so Western Alaskan chum are caught as bycatch in the state-managed Area M fishery as chum migrate between the Gulf of Alaska in the winter and the Bering Sea in the summer. An Area M fishery includes purse seines, drift gillnets, and set gillnets. And I wanted to point out that Area M total chum bycatch is higher than the pollock trawl bycatch. And unfortunately, there's limited genetic studies, but those that have been done show higher proportion of Western Alaskan chum than the pollock trawl bycatch. So I think samples were taken from 2007 to 2009 and estimated about 30% of central Western Alaskan origin. That's associated with about between 200,000 and 500,000 Western Alaskan chum, depending on where you apply those proportions, which year. And then in 2022, a study estimated about 13% of chum bycatch was from central Western Alaskan origin, which would have been associated with about 100,000 Western Alaskan chum. And then in comparison, here we get to the only lever that the North Pacific Fishery Management Council can pull, which is the salmon bycatch from the pollock trawl fishery. So the table on the left shows total chum caught as bycatch each year, which the lowest year was 22,000 in 2012. And the highest, unfortunately, was 2021, which was 500,000. But on average, it's about 267,000 chum, which is, less than those other contributions. And then 2024 is not on this list, but it was almost as low as 2012. And then the table also shows the average percentage from central Western Alaska and Yukon, as estimated by our friends at NOAA geneticists. And then these proportions are by genetic area, cluster, and time period, so they can be applied to the total chum bycatch to approximate the number of chum likely from Western Alaska in the fourth column. And our speedy a key point of this problem is that our speedy NOAA geneticist collaborators churn out the genetic stock composition analysis as fast as they can, but it happens after bee season is over. So during bee season, the fleet is catching chum, and we don't know exactly what the stock proportions are, or we haven't known. And I think it used to take a year for the genetics to come out, and then they increased it to April. And then this year there was a special February meeting, and we saw the preliminary estimates there. So that was the fastest it's ever been, but it's still after the damage has been done. And so the figure on the right shows the reported sources of chum commercial catch and escapement. So the yellow and khaki colors are all like a bunch of commercial catch and escapement that we found, that we gathered. And then the tiny red bars at the top indicate the estimated Western Alaskan and Yukon chum bycatch. And these bar plots don't include subsistence or escapement from any other river but the Yukon. So it's just to get an idea of the scale of the issue that we're trying to manage. So the little red bar is the only lever that the North Pacific Council can touch, really. And then in addition to that, not all the Western Alaskan chum that are caught as bycatch would survive the marine environment. So adult equivalency analysis, or AEQ, estimates the number and impact, or the proportion of total run size of bycatch that would have survived at sea and then returned to natal rivers. And then the impact rate can only be calculated for the Yukon, where the run size estimates are most reliable. So this top figure shows commercial and subsistence chum harvest in blue and orange bars. And then the tiny green part at the top of the bar shows the estimated number of the adult equivalents, or AEQ, central Western Alaskan chum that would be expected to have returned. And then the blue line shows the proportion of AEQ, central Western Alaskan chum, related to total removals, which lingers around 1 or 2%, but then increased to 8% in recent years when fishing has been closed. And then the lower table shows the adult equivalents, or AEQ, Yukon bycatch compared to the fall chum run size on the Yukon, and shows that the impact rate of Yukon chum bycatch on Yukon returns is less than 1% on average, but hikes up to 5% in 2021 when the chum returns were low and bycatch was high. And so the options on the table for the North Pacific Fishery Management Council, in order to improve Western Alaskan, with the goal of improving Western Alaskan chum abundance, are all related to limiting chum salmon bycatch in the pollock fishery. So the options are the status quo, a hard cap on total chum, similar to Chinook, a cap on total chum, which varies based on an abundance index, so it would give relief to the fishery when the returns are high, and additional requirements within IPAs, so stricter requirements that are currently in place with status quo, and really large spatiotemporal closures to better target Western Alaskan chum. And so I wanted to show how C-State uses our detailed spatiotemporal information on bycatch to examine these alternatives. So everyone looks at the genetic estimates of stock proportion by year, cluster, and time period. So this is the figure on the left, shows the average proportion of Western Alaskan chum by cluster from NOAA genetic analyses, just the average from 2019 through 2023. And then those estimates also have early and late time period. So this is kind of like a rough estimate, but the spatial pattern tends to remain where cluster 1 has the highest proportion of Western Alaskan chum. And then we have total chum bycatch at the haul and fish ticket level, which we can aggregate up to the statistical area. And then we can apply the estimated stock proportions to visualize the estimated Western Alaskan chum by haul or fish ticket. So the map on the right shows how Western Alaskan chum are mostly caught in the southeastern region of the Bering Sea along the shelf edge, and much less in northwestern regions, which are mostly Asian hatchery chum. And so then we can use these tools to examine large-scale patterns, for example, demonstrating how about 70% of estimated Western Alaskan chum bycatch is taken from clusters 1 and 2 prior to September 1st. So if this figure shows the average percent of annual Western Alaskan chum by cluster. These are the clusters used in the genetic analysis. So this is the best, finest scale, spatial scale information we have. From June and August, the proportion in clusters 1 and 2 is much higher than after September 1st. And we can look at mid-range patterns to identify statistical areas that most frequently have high Western Alaskan chum bycatch rates. So the figure on the left shows the total chum bycatch rate, where gray is low and red is greater than 0.2 chum per metric ton of pollock. And then the figure on the right shows the estimated Western Alaskan bycatch rate on the same scale. So that's why we're catching total chum all across the Bering Sea, but then when you actually look at the proportions Western Alaskan, it's much finer scale. And then the number, it's hard to see, but the number in each statistical area is the number of years from 2011 to 2023, where the bycatch rate was greater than 0.2. And then I also show the rolling hotspot closures on top of each map, just to get an idea of like where we move the fleet around in relation to chum bycatch. But I like identifying which statistical area is kind of always a low-hanging fruit for having higher Western Alaskan chum bycatch, to help the industry identify areas that could be Western Alaskan chum corridors. Given the fact that we don't know the genetics in season, we can look back at previous years. And then we also look at finer scale patterns by applying the estimated proportions of Western Alaskan chum to VMS tracks. So we based on the VMS tracks statistical area and time period. So this helps visualize where fishing is cleaner within a statistical area. So for example, there's this area, the horseshoe. This is that's down here, is a really important fishing ground, and it's generally very clean fishing at deeper depths. So that's an example where there's heterogeneity of chum bycatch within a statistical area, and that feels unfair to the industry for that to be lumped in with this huge cluster. Like the potential to close down the whole cluster when that area of fishing is really clean. We want to be able to analyze where the chum are actually caught within a statistical area, and looking at VMS helps with that. And then one of the alternatives is this idea of a corridor area closure. It proposes that if X amount of total chum are caught in, for example, cluster 1 or in cluster 2 during a certain time period, so from June through August, then they would close the corridor until August 31st. So this has the potential to close these huge swaths of the Bering Sea, potentially for like all of July and August if the chum came immediately. So we wanted to look at what would happen if fishing effort was displaced from cluster 1 or from cluster 2. So the left figure shows the average proportion of Western Alaskan chum by cluster. And just looking at it, everyone might think that a closure should happen in cluster 1 because it has the highest proportion of Western Alaskan chum. But the middle figure shows that there's a much higher total chum rate on average in cluster 2, which is right here. So there's the total chum rate in cluster 2 on average is 0.104, whereas in cluster 1, it's a little less, it's 0.08. Okay, but then on the right graph or figure is total pollock. So most pollock in the whole across all sectors is taken in cluster 1. So if you close cluster 1, moving effort from cluster 2 to cluster 1 ends up being risky because there's higher proportions of Western Alaskan chum in cluster 1. So that doesn't feel like the right thing to do. It quantitatively also is very variable across years, whether that would work out in your favor if you look at the data each year. But then moving from cluster 1 to cluster 2 is really risky because there's higher total chum rates, and you'd have to move much more pollock fishing into other areas to meet the quota. And so then that could be, because you're catching more chum overall, that could be associated with more Western Alaskan chum. And so neither of these options was a winner when it was analyzed by the council staff. And that kind of brings us to the current situation. There's a couple other options on the table now that we're looking at. But what have we learned? So in 2021, way too many total chum were taken as bycatch on the shelf edge. And so this map shows VMS tracks by the shoreside sector just for 1 week, where red tracks show where the chum bycatch rates exceeded the base rate, and white is cleaner fishing tracks. But you can see there was a ton of effort. I'm not in the right place. A ton of effort right here along the shelf edge. And I think the story was they were had issues with storms. And honestly, at this point, I don't think the declines of chum were such that people were really worried about this issue at the time. And then because there was such high total chum bycatch in 2021, and there was starting to be indicated that fishing couldn't occur in river and the chum returns were low. In 2022, the shoreside sector set an objective of reducing chum bycatch by 200,000 chum. And they set chum advisory areas on the shelf break there where they had caught a ton of chum the year before. And so the map on the lower left shows the number of fishing events by statistical area, where the effort shifted from the shelf edge up northeast onto the shelf. And then the map on the right shows the rolling hotspot closures in 2022, with the red closure here was in effect for 3 weeks as an advisory area. So they were really not messing around. They had this goal of cutting total chum by basically by half. And they did succeed. So the shoreside sector succeeded in cutting total chum bycatch in half, but they actually caught more Western Alaskan chum than in 2021. And so they moved up onto the shelf and they avoided total chum, but unfortunately had a much higher proportion of Western Alaskan chum and ended up, having the total chum that they caught, but catching a little bit more Western Alaskan chum as estimated by the genetics. And so in 2023, we meant to continue trying to avoid chum, but this is just an example of how each year the dynamics change so much. So the pollock were much further north, and so the catcher processors could just go up north and catch cleaner pollock. But half of the shoreside fleet can't move all the way up north, and they became challenged with herring bycatch inshore. And so this brought up another complicated issue. If they had exceeded this herring threshold that has been in place for a very long time, that would have closed out catcher processors fishing cleanly further north. So it was so dramatic. It was like if they caught any more herring, it would close this really clean area of fishing. There's a herring savings area up there. So in order to avoid herring, because they are all working together, the shoreside fleet moved around more than they would have. So they ended up getting on top of and catching more chum than the areas that they had been catching high amounts of herring. And so thankfully, most of those extra chum that ended up being caught were hatchery chum. And this was a relatively low Western Alaskan chum bycatch year, but it could have been better if they weren't trying to avoid herring also. But this demonstrates the trade-offs happening in season, both between and among bycatch species. And we find it very important to point out the implications of a hard cap. A hard cap works really well for Chinook because the fleet is trying to avoid all Chinook. But a hard cap for chum would change the incentive of the pollock fishery to avoid all chum, and that's mostly Asian chum. And so this was the exact issue demonstrated between 2021 and 2022 when the shoreside sector essentially put a cap on themselves. And if the fleet moves to areas with lower total chum rates, essentially lower rates of Asian hatchery chum, those areas could have higher rates of Western Alaskan chum. So in summary, C-State helps mediate between council staff and industry partners to find a more practicable solution to meet conservation goals. So we participated in this ongoing process of analyzing these alternatives for chum. And honestly, C-State has more intimate knowledge of fishing dynamics than council staff and NOAA scientists because we're at the industry meetings, we're hearing discussion from skippers on what drives fishing behavior. We're hearing co-op managers and captains brainstorm what they can do to avoid total chum. And they bring up issues balancing pollock CPUE and other industry requirements that as a scientist working in stock assessment, I just had no previous knowledge about. And then we also maintain our close connection with NOAA scientists and try to bridge the gap between science, industry, and policy. And so in summary of our whole program, C-State integrates large networks of vessels based on partnerships that allow for communication across fleets. Legislative approaches take several years, but our partnerships allow us to react to crises in the middle of the season. And it's really important, especially in these days, to emphasize that our programs rely on a large network of vessels fishing, meaning we have information on where bycatch rates are highest. So the more consolidation that occurs also is kind of like less data, but it's important to think about. And then we need access to observer data and landings data, catch accounting, and VMS. And then we rely on our partnerships with government scientists, academics, and multiple fishing companies and cooperatives. And we're really open to figuring out how to bring the best available science to fishing cooperatives to best meet both conservation and industry goals. So I'm always loving hearing from academics or scientists on what models you're using about different species distributions in the Bering Sea, and we try to think about how we can bring that into what we're doing over here. Thank you so much.
We're about 10 minutes for questions before we go to our entertainment for the afternoon. Rita.
This is a little bit of a political issue.
It all is.
NOAA is a federal agency, and they run the observer program. And do they make their data available to everybody rapidly? And so what I'm trying to figure out is, and check my assumption, there are fleets that contract with you to give them faster information about where they can fish without too much bycatch. So this isn't NOAA that's doing this is your private company that's doing this. And I presume you have, what, 80% of the fishing fleet that contracts with you, or 20%, or?
In the Bering Sea, yeah, probably more than 80% of the.
More than 80%, okay. So you're providing a service which is kind of based on what NOAA is collecting. If they close down NOAA.
We've thought about this.
Are you prepared to take over?
Run an observer program?
Yeah. Well, you went straight to the heart of the question here. Yeah, we always have keeping our options on the table. What we do depend on is the infrastructure that NOAA and Federal Observer Programs built. Same thing with the shoreside and fish tickets and everything else. We're effectively parasites with data sharing agreements from every vessel and captain that says, I agree to share my EMS data, my observer data with CSA. So we have signatures from hundreds of captains every year that share their data with us. What has happened already that isn't intuitively obvious is we've shifted from human observers to electronic observers in much of the fleet. So almost all of the shoreside vessels now have video cameras on board, and we're having problems driving the video cameras quickly. I get that. But the difference between a human observer and a video camera is the human observer has a neck, and they can collect other information about seabirds and other data that a camera can't always collect reliably. So we do lose some of the information, but then we also gain a huge amount of information from the automated video production data and the VMS data. So there are replacements for what's going on. A lot of these federal observer programs are contracted through independent companies. So it's not like these are NOAA staff, these are contracts going through NOAA. So we worry about that. But yeah, if the whole federal observer program or the requirements for an observer program disappeared, the CSA wouldn't be in business. We wouldn't have to have a rolling hotspot program that is our bread and butter of what goes on here in the CSA. So
That's what I was thinking is if the observer program collapsed, then the requirements for conservation probably would not be there either. And yeah.
The key thing though is enforcement. If there's no enforcement either, there's also no need for us because nobody's checking the books. So we have an annual audit process that we go through with an independent auditor who basically takes all of our closed area polygons, all the VMS data, and then randomly checks to make sure that there aren't any infractions and stuff. But the same thing with OLE, the Office of Law Enforcement in Alaska. They need to have procedures in place to implement these programs too, to make sure that the vessels have the VMS on board and it's operating.
So there's a limit to which private industry can replace the federal government because you can't make the regulations.
Correct. Yeah, it's the regulation. What gives us the power is the incentive plan agreement, that legal document these captains sign that says we agree to do this and we'll be held accountable. So without that kind of infrastructure, at a large scale, it wouldn't work. At a smaller scale, these cooperatives, we do have what I call them informal cooperatives that have no legal documents at all. They're just four friends that have agreed to share a cod quota that they deal in. We manage that for them, but there's no legal requirements to do that. Great question.
Okay, now about science question. Trevor.
Have you worked with the chum salmon biologists? Because with these data, you can basically track where the migration routes are, and where they're traveling, when they're traveling in and out. It seems like there's potentially a ton of information for salmon biologists in these data.
I would love for them to contact me because that's what we're trying to identify. Yeah, now because the large scale closures kind of showed that would not work as intended, we're trying to find smaller corridors that could be closed. And so we're looking really intimately at the bycatch data. And I didn't mention this, but I'll bring it up now that there's a new program from the Bristol Bay Science and Research Institute that's trying to do in-season genetics. So they did a pilot program in 2024, which just so happened to be an extremely low chum bycatch year. So we're hoping it can scale up when there's inevitably going to be, and hopefully not, but there might be more chum bycatch. But they basically compared it with the NOAA genetics that came out after the season, and it was really similar. And so we're really excited to look at week by week genetic information. There's going to be a ton of work to go along with that and figuring out like what spatial scale it happens at, and but it's a lot more information than we've had before. And so that will actually, if any chum biologists want to contact us about looking at bycatch patterns, we have bycatch patterns already. We have like post-season genetic information, and we're hoping to only improve with this weekly genetic information. That would be cool to work on. I'm sure, I hope it would improve the chum population issue.
The,
Is that-
the principal problem is we're not a scientific survey.
Yeah.
We're out there trying to make money catching pollock. So we're not doing a grid, measuring chum and trying to cross section to get a genetic sample or sample the genetic diversity out there. We're trying to make money catching pollock. We set up those 3 experiments there over the years at great expense to the fleet to try and learn about where we suspected a large cat would benefit a hatchery fish. Because we knew that the Western Alaskan fish from the RAM fishery were close to the Aleutian Island chains. If we could keep the pollock fleet away from the Aleutian Islands during the months of July and August, that corridor area, we could do a lot. But they said, no, it's in cluster 2 is the problem. And so we shut that down, sent them down there and said, see, we told you this would happen, and that's what happened. And so we were going to repeat the experiment the next year, but the chum didn't show up.
We've seen every single year has a different story. So it's certainly not a scientific experiment, but I'm assuming that it's hard to run these experiments. If they haven't started yet, it'll take a while to get there. So I think that it's also information is better than nothing, but it is not scientific.
I've got a question.
I have a question. Not as sciencey as probably you're hoping. So I'm wondering, like, this issue, especially as it relates to sort of the idea of like public comment as part of the North Pacific fisheries management process. As you mentioned, like within the past 5 years, it has sort of become what it is, and of course within the last 2 has been where it's like really picked up steam, and especially within like industry folks actually commenting on it, like yourself included, as far as like sea state goes. So I was wondering, like, do you think that's just a result of them doing the EIS analysis and then having, I don't know, like having these alternatives listed and there being this sort of like action item that you're building up to, as opposed to like communities that have been commenting on like low returns and chum salmon and things like that previously, and just the timeline of it?
To comment on the industry participation, yeah, when these issues come up and there's important topics that can affect the bottom line or how those vessels operate. We have members here from the United Catcher folks and some processors association in the audience here today. They lobbied their captains hard to try and either call in or show up and participate. I probably learned more from 3 skippers about Bering Sea pollock fishing than I ever learned from any academic course or professor that I'll ever. Just their experience on the ground is very valuable, but when they come and testify to the council, listen, these people are trying to do the best, make up rules that make sense, but they don't know the ins and outs of how a pollock vessel works and how a pollock fishing works. So it's important that we show up and have that public process and say, listen, what you're proposing won't work, and here's the reason why. And also it's important to offer up alternatives and say, listen, we've looked at the data carefully and we think this would happen. I'm pretty sure we would have had a large scale closure cluster in cluster 2, if not a coastwide cap on chum salmon by now, had Sea State not been involved in this whole process of participating in developing the policy.
Good. You beat me to it, I think.
Yeah, you asked your question, you can do better than that.
I doubt it. Yeah, so I had 2 questions. I'll answer them both, and you can choose which one to answer. There's obviously, this is all within the council process, but it seemed to me that the Area M fishery is killing just as many chum, but that's a state fishery. I'm assuming that that's because legislatively the chum, the bycatch isn't an issue at the state level legally. Because it seems like if you're dealing with it, I mean, dead chum are dead chum, and putting all the pressure on the federal side seems ludicrous. But maybe you'll disagree with me. But the real science question goes to Trevor's point about the in-season genetics. I was wondering, has anyone thought about what the value of in-season genetics was? You sort of went the one way. So if we've got genetics, this is cool. But I think from the point of view of being more efficient in terms of in-season management, you could probably quantify the reduction in moving pollock vessels as a function of the cost of genetics. Genetics is great,
Oh,
and
interesting.
one of the great things about geneticists is you give them money, they do things. And in this sense, that there's actually value here for doing it. And I was wondering if you guys have thought about, ignoring the area M politics, can you work out sort of the value of having an in-season management approach rather than having to do this sort of retrospective, catastrophic, relook what happened last year.
I'll answer the first one first, I'll give Merrill the second one. Yeah, the state manages the salmon fishery and the federal fishery managing our salmon bycatch. So it's two agencies with conflicting issues. It's just
And I think it comes up in testimony a lot, as everyone's like, but what's happening with Area M? It's kind of, I felt like just a question that no one has answered. I hadn't thought about it like the value function. I think we're just so excited to have information and move it around. But I wonder, I could ask our industry partners if they've thought of that, because that would be, an interest. Are you saying that they could start doing that in Area M also?
I wasn't putting
Okay.
area in, I was just saying, if you could value getting those data, if I was industry, I would make sure I get those data if it's going to
Yeah.
save me a large size.
I will say, I think the industry is extremely excited about it. I don't know if they've even, I think probably inherently, because they maybe won't have to move as much if the genetics come back. So yes, I think everyone has that in mind. I think we're trying to figure out scientifically because we're trying to work with the scientists at BBSRI to think about how and where and how many samples they should collect. I think what was that like? Because the data collection on our side is not scientific, and they are moving to find pollock, so they're not going to just keep going back to the same areas necessarily. Have you thought about? Yeah.
There's a lot we don't know with the genetics program. It's a 1 in 30 fish sample. Right. So you actually have to test quite a few chum before you can actually start to learn anything. So having this independent program allows to increase the sample rate. We don't know whether, when you go out and catch a school of pollock, catch a net full of pollock and catch 300-400 chum, you don't know whether those chum are all the same siblings or from the same stock, or if they're mixed stocks. So we've done some preliminary stuff that shows that they're mixed from everywhere. But we don't know once you get into certain areas do they start segregating. So there's a lot you can learn. The part that I find terrifying is that even if the pollock fishery didn't exist, we would still be here today with this exact same problem. We're talking about those little tiny red bars you saw on my graph. That the 1 pixel thing is what we're talking about saving. So sure, it's exciting to have in-season genetics, but we're really trying to save literally a few hundred chum salmon that are swimming around with hundreds of millions of genetic clones from a hatchery.
We'll come to regulation. Last question, Tim, and then we'll break for.
I was thinking a lot about your experience of sort of like seeing kind of quasi real time. So what's the consequence of putting in some sort of spatial regulation? And it just occurs to me that, that's the thing that academic scientists and others do a lot of interesting work on sort of fleet dynamics and it seems like you have a level of detail of data that most people would love to have. So I'm really interested in the broader question, like what are some of the things that you've seen working with C-State of like, wow, I never would have expected that.
Yeah.
There's like things you've learned about how the fleet responds to things.
I'll respond with, I've always said to everyone, I feel like the fat kid in the candy store in terms of the access to the data and the information I have. As a fishery scientist, we just crave this kind of data, but the level we get is just incredibly detailed. I would say that the biggest thing I learned just by looking at the data had nothing to do with pollock fishery. It was a groundfish, flatfish, trawl fishery, avoiding halibut. And in real time, I was watching a fishery occur. It's a place called Togiak. And what happens there is the yellowfin sole move up to spawn. And then right as the spawning starts to hit its peak, the halibut come up and start feeding on all of this spawning activity going on. Well, the fishery gets up on there when the souls are aggregating, and they'll start doing what I call mopping up the school. They'll just draw back and forth and mop up the school. And they go from basically off or inshore to offshore. And what happens is they'll trawl, and then they'll hit halibut rates. And then the fleet moves back inshore. We trawl, and hit halibut rates. We go up. So they actually find where these halibut fences or boundaries are, and as the cold water moves and pushes them, the fleet will sit right on it. That's why I say we use a lot of environmental temperatures, so we're putting that in. Yellowfin sole is an incredible fishery. When there's a lot of ice, you can fill this room in probably 10 minutes of fishing. Floor to ceiling with yellowfin sole. They're so aggregated. What happens is that cold water, as it moves, it's like a fence. And so it's herding all of these fish up to this, basically this cold line. The fishermen find that line, and then you go in there and get very clean yellowfin sole. No bycatch whatsoever. In years where we don't have ice and there's no cold pool, that nice thick fishery doesn't show up. And so what happens is the yellowfin sole spread out, and our halibut bycatch rates are just high everywhere. We can't avoid them. The halibut don't aggregate up and they don't segregate. So that's probably one of the things I learned looking at the detailed data that just shocked me. How close they are. It's literally from me to the other side of the room, and then they're out of it.
Okay, it's a great place to stop. We can have additional discussions on what Steve has learned over the years. Let's give a thank you to both Merrill and Steve.